Welcome back to my channel. Today we're looking at logarithm. We're going to be solving a few logarithmic equations here. So the first one, this is number one, and it says -2 log in base 5, 7x is equal to 2, and we want to solve for x. All right, what we can do here is there are multiple approaches, but what we could do here is since this is multiplying here, we could divide both sides by -2 so as to make this a little bit more simpler. So I could divide this side and that side, or we could divide through it by -2. So when we do that, on the left side, a -2 into itself will give us 1 times log of 7x in base 5 is left on this side. And that this is equal to 2 divided by -2, that's -1. So this is a -1. Now, the next move is that we could definitely take the base raised to -1, and it's going to equal to this argument right there. So we could definitely say the base, which is 5, raised to -1, and this is equal to the argument, which is 7x. And that's what logarithm is about. What power can I raise this to give me this? So since it is -1, so we set it up. 5 raised to the -1, it really means 1 over 5, okay? So this means 1 over 5 is equal to 7x. And in an effort to find x, we just divide both sides by 7. So because the 5 is in the denominator, then under here we'll have 5 times 7 because we're divided by the 7. So this is basically 1 over 35, and 7 cancels itself 1 times x is actually x. So there it is, that x is equal to 1 over 35. And that's our first question. Let us take a look at question number 2. So in question number 2, what we have is -10 plus log in base 3 of n plus 3, and that is equal to -10. One of the things that you could do is to isolate the log and get the numbers on the other side. So what I'm going to do is this -10, I'm going to add 10 to both sides. So we are adding 10 to both sides so that we can have the log by itself. So what I'm left with is this becomes 0. So we have log in base 3, and then we're looking at n plus 3. And this is equal to 0 because -10 plus 10 is a 0. What this is suggesting now, we could take 3, raise it to a power of 0, and let it equal to the argument. So 3 raised to the power of 0 is equal to n plus 3. Remember though, in exponent, anything raised to the power of 0 is 1. So 3 raised to the 0 is 1, and this is equal to n plus 3. Thereby, we're going to subtract 3 from both sides. So on the left side, -2 is equal to n. So that is our second response there. N is equal to -2. Our third and final question here goes like this. It says log x plus log 8 is equal to 2. Whenever we're adding logs, all right, of the same base, and you could see that both of them basically the same base. Whenever you're adding log of the same base, what we definitely could do is write it as a common log on the left side. And then because you're adding, you have to multiply the argument. So this 8 and x becomes 8 times x, which is 8x, and this is equal to 2. So I took the left side, represented it as a single log, and it is equal to 2. What we could do now is that because there was no base here, I could just represent this as base 10. And then we're just going to represent how we rewrite our logarithm in exponent form. For example, 10 raised to the second power is equal to 8x. 10 raised to the second power is 100, okay? And 100 is equal to 8x. In an effort to find x, I'm going to divide both sides by 8. So, so on the left side, we could break this down. If we work through this by using 4, we're going to get 25 over 2. and that is equal to 8 into itself one time x. Remember, 25 over 2 is the same thing as 12.5, which is equal to x. So depending on what you want to do there. Thank you for watching my channel, and see you next time. We will be looking at another segment on logarithms. Bye-bye.